Hello, welcome back. This is going to be video number 10, and this is where I'm going to reassemble this old 4-speed gearbox, and with a view to having it as a spare. My intention is that it is as functional as it can be, and I'm just going to start off by a little bit more analysis and examination before I start the assembly process. I'm going to take off this clutch actuator and take out the threaded ring with my special tool here, and I'm going to have a look at the bearing. I'm just going to release this and swing that out of the way. I'll go that way, and then this should just lift up. Right, I've just removed this threaded ring and the dirt sheet or the oil shield, and as you can see, this is a bronze bearing in here. It's in good shape. Yes, I'm just going to seal that up. There's no slack in it. It's smooth. A little bit of sound effect because of the bearings rubbing on the dirt shield, but I'm at peace with this. This is good. This can go back together. Right, that's it. Now, you've already seen me put this back together on the 5-speed gearbox. Essentially, it's a good idea to make sure that this bearing hasn't moved, that the threads are still intact, because sometimes people can overdo the threads. They're quite a fine pitch. And I've just confirmed now to my satisfaction that this is all okay, and it can be sealed up again for another 20 odd years. I've also just put a load of oil in on top of it as well. So that's about it. It's just a question of keeping going now with this until the thing is bottomed and giving it a good tweak, and then mushing over the aluminium to lock the thing in place. That's better. Right, so the camera's in the way again. Right, I'm just about to put this back into the gearbox, and I thought before I do that it would be interesting just to show you in terms of engagement. These gears here, even in the red book, are determined as, or this assembly is determined as, unlikely to need attention. I've just checked the end float on the bushes, the radial displacement and clearance. It's all nominal. This is as good as it ever was meant to be when it left the factory. So this sliding dog here moves in and out and is virtually level with the end of the gear, and the same over here. It's virtually identical, similarly level. There's very little wear evident on any of these dogs, and I'm happy to put that back in pretty well as it is now. What I'm going to do though is just check. If you think about this, this is mounted on a pin. This is the selector plate. Ooh. This is the selector plate, and once that goes in, that pretty well is a datum. And what I need to do, given that this can only rotate, it must stay on center, I need to just make sure that the selector fork moves these, or this sliding dog, in the right amount, because one of the things I can do is shim the lay shaft up in that direction or shim it back in that direction to make sure that I get an equally good engagement on either of these gears. And that's what I'm going to try and do now. And I'll come on to the main shaft then, and all that goes with that in a little while. Right, I'm back again with this little camera, and what I'm going to try and do is confirm. Actually, it gives a very good view. So if I put that in there, in fact it might even be better if I slide it down there. Yes, that's good. My intention now, the next stage, is to install the sleeve gear. Many years ago I put some shims on this. I made these in the lathe to put this gear where I thought it needed to be in order to get as much mesh on this gear with the gear on the lathe shaft, and that's an essential ingredient really if you want to get good load areas and so on. So that's the next stage I'm going to look at. I'm going to put this in, clamp it up, and then see how that engages with the lathe shaft. Right, this shows the clutch and the spacer and that threaded ring all clamped down on its spacer, which means that in effect the sleeve gear is tight and fully engaged in the bearing, and it's in its final position. I'm just going to take this sleeve gear out again. I'm happy with the mesh, but I feel the need to talk a little bit about wear patterns and so on gear teeth, and what we can sensibly hope for when we're building something which is mature. In the first place, if you take your average main shaft, that's mounted with a bearing on the end. Nominally, that means that this, even though there will be a little bit of radial clearance on the bearing, this is going to be staying put. But out at the other end, where the sleeve gear is, first of all, you've got the big output, the main bearing here, which also has radial clearance on it. So in theory, the sleeve gear can go in that direction, and it can also twist a little bit. But inside that you have the bush, and that means, and there has to be clearance wherever you have bushes. So the red book says no more than 1 thou clearance, and it has to be a board rather than reamed hole, and that probably is applying a minimum for fear of the bush seizing to the main shaft. But for whatever about that, I've got a little bit more. I've got about almost 2.5 and so on. So I'm happy with this mature fit. But what it means is that the main shaft can move around within the scope of the bush, and that means that wherever you have bushes, and indeed on the lathe shaft here, these gears are, well, if I move that sliding dog, these gears are also on bushes. That means that once the lathe shaft is there, the gears can spin around with no load, but as soon as there's a load, they will move, and the bush will allow that. So that means that the mesh on the teeth will alter, and the gears will become comfortable with these gears up here. And there's no arguing about it really. You can be pedantic about wear and geometry, you can draw parallel lines on a drawing board, and you can get AutoCAD to do it, and even high precision machining. But once you introduce bushes and clearance, inevitably these gears are going to end up not only moving within the scope allowed by the bush, they'll move a little bit because the bush needs clearance, and arguably they'll be able to rock as well. So they'll sort themselves out, and there's no point in being pedantic then about the contact patch or evidence of wear. My expectation is that these gears will all thrash around together. These 2 gears here, or 3 gears on the main shaft, are very new in compared to the gears on the lathe shaft, and that means they're going to have to spend a bit of time getting used to one another, and that's where I come in. Lots of oil changes, lots of examination on the little magnet, which should, I have a little magnet here in the drain bung, and it can be security wired. So that goes into the gear oil and it soaks up any debris. And what you should find on a magnet is really a little fuzz of dark microparticles. if you end up seeing large lumps and which reflect the light, chances are you've got something, you're in trouble. So in fact, I have only ever had one gearbox disaster, and all I can say is I was very glad to have it contained within the gearbox and not sharing engine oil. I'll put some photographs up now, and you can just have a quick look. You can just move ahead if you're not interested, but we don't often see catastrophic gearbox failures. This was on an old Triumph T150, that old thing behind me, and the root cause of it all in the end was the shock absorber rubbers had become swollen with oil. And you know, rubber is not compressible, it's not a gas, but it can be deformed. And if it's going to be deformed, it needs space to deform into. And when these cheap, simple pieces of rubber swell up with the effect of oil and fill all the space available, then in effect the shock absorber stops working because there's no movement possible. And that is the event which I believe triggered the failure of the gears in the gearbox. So anyway, look, have a look at these photographs, or skip ahead if you like. From my perspective, the way this gear here meshes with the gear on the lay shaft, the width of the gears is virtually identical, and as you will have seen from the little micro camera going in there, that the surfaces of these gears are virtually, you know, in the same plane, and that means that this gear and the sleeve gear will have as much possible mesh, even allowing for irregularities in the wear pattern of these gears and so on. But all of that with time will sort itself out. Okay, I'm going to stop now. But I've now got the lay shaft in and the appropriate selector and the sleeve gear. The next stage now is to do some work on the main shaft. Well, the first thing I've done is put this first gear on, and then the bearing, which will be in the outer cover, and the nut. And the first thing I discovered is that by tightening this up, and not even in tightening it very hard, this gear won't turn. So clearly these bronze bushes in here, they look like they're fully in, but they're clearly too wide for the machine's surface on the main shaft. So I'll have to do something about that. And it's pretty easy to put it in the lathe and take a couple of thou off and try it again. But I need to make a decision, because in effect this part here can only travel so far when it's controlled with the selector fork, and I need to decide whether I take metal off the front of that bush and allow that gear to go forward, or whether in fact I need to take it off the back of the bush, or one at the back of this as it were, and let it come back. All I need to ensure is that when this is moved to its full extent, this gear and this one just mesh together without any loading being applied to the selector fork. Obviously I'm looking for maximum engagement here for long life and so on. So this involves another little bit of analysis. I'll take this off. I will do what I've done before for the 5-speed. I will put the end cover on, put the main shaft in, tighten this nut down, and then I will locate this end of the shaft in space with that adjustable stud, and then I'll take it all apart, and with this as in its proper position, then I can see where this part is going to be and make a decision on whatever machining I have to do on this gear. One of the other essential checks that has to be done when you're looking at the main shaft is just to look for wear. wherever the sleeve gear bush rubs on it, it's possible for this shaft to be worn. I've seen some of them that are down quite a bit. Obviously the bronze bush tends to last a little bit longer, and it's the hardened shaft that seems to suffer. As it happens, the shaft I'm putting in, there is a barely perceptible suggestion of a taper, and I'm happy with that, given that this is mature. So anyway, it's something which is easily checked, and yeah, just almost, there's barely perceptibly half a thou in, anyway, I'm happy with that. Right, you've seen this before. This is where I put the main shaft in, secure it with the nut, so it's secure in the bearing. This is bolted down, it's not going anywhere. And then over here I've got this simple piece of stud and a piece of old plate just touching the end of the shaft, and that means when I take all this away and undo this nut and the whole thing comes away, I'll be able to position the main shaft in exactly the right position. But I've come up with a problem. Now that's in top gear at the moment. If I go through the gears, you'll see stuff moving around, and then I want you to look at this. This is the new gear which I plan to use, and as you can see, the bush here is level with the dogs nominally. So what I expect to see is, I expect to see this surface come to the end of these splines, because the splines are what the bush butts up against. So I need to just confirm what's going on here, because I think in effect this can only move so far because of the constraints of the selector plate and the selector fork, but I don't think this moves enough. Now this is in the right position. When the nut here is tightened down, this surface here is secured against the side of the ball bearing. Now I could put a spacer on that, and I may yet have to do that, but let me show you what the problem is here. Neutral, and now see how this moves into first gear. These splines, yeah, that's still in the right position. These splines are not really level here. I need to just have a look at this. So if I put this one on now, I think this is a job for the little micro camera again. I need to get in around the back of this so I can see better what's going on. Right, I'm just going to start playing around with this little camera again, and the plan at the moment is to try and work out what the mesh is like and what the engagement is like. Let me just rotate the thing around now. I'm looking at it in the monitor on the laptop as well over there. So I need to just get things lined up. Right, there's been a slight change of plan. I made a decision, given the fact that this bearing in here dictates where the splines are and where that shaft, the main shaft, actually locates. I decided to have a look at where the bearing was, and I found that the bearing was not up against this flange down here, which is where it should be, but that in fact it had migrated out and was up against this circlip. And that means in effect that the shaft, the main shaft, and the bearing have moved out a little bit, which might explain the discrepancy. So before I waste time with a little micro camera, I've bought a new bearing. I'm going to dig the shields out of this and install this, and then I've got some shims, and I'm going to shim up the bearing to make sure that there is no gap between the circlip and the bearing, and therefore the bearing is going to stay put, and that should keep the orientation and the geometry of the main shaft under control, which hopefully will mean that I don't have to indulge in all sorts of machining to get this get the mesh on the gear. Anyway, I'm glad I decided to think about it. I thought about it overnight. It's always a good idea to have second thoughts. Anyway, lots to do. Well, the first thing I'm going to do is put this, having put the bearing in, I'm just going to put this snap ring in, or circlip, and then I'm going to see what I can measure. Right, let me just have a little push on that. Right, that's now, yes, I'm happy that that's home. Right, now I need to just see what I can get by way of a feeler gauge in there. 15,000. This is the dodgy feeler gauge where certainly some of the blades on it seem to be a little bit ropey. Well, I've just tried an 18 that went in. Now I've got a 10, a 6 and a 4. That's 20. So let me just see if that will go in. No, that won't go. No. Okay, let me just go back to an 18. Right, here we go again. I've been very fortunate with the shims I had in stock. This gives a thou clearance, which is fine. So I just need to try and make sure I don't launch this circlip. Well, that's all I need, a magnetic screwdriver. Right. Right, that's protruding a little bit too much. Right, that's gone in. Right. This isn't working that well. The circlip isn't going in straight. Right, I think that's a little bit more promising. Okay, I shall just gently tap that all around to make sure it's firmly seated now. Well, I've just had to reset this plate over here. Tightening this up into the bearing in the new position has definitely altered the geometry and the position of the main shaft, all in the right direction, I might add. So let me just get this nut off again. Okay, I'll just take this cover off again and reposition this shaft and have another little look. Well, as you can see, I've set this first gear up on the lathe. The run out here is less than a thou, well, about a thou on the perimeter of the gear. The deviation in here is going to be very, very little. And what I'm going to do now is just take about 5 thou off the face of this, because I need a little bit of running clearance anyway, and I want the gear to move inboard a little bit so that it will increase the mesh, and it will also ease the lockup situation, which I discovered when I tried to tighten the nut down with the bearing in place, because these bushings are just too wide for the journal length that's available on the main shaft. Right, I've just machined this gear, and that's it. There's visibly a couple of thou between the end of that bush and the start of the flange. I think the correct clearance is probably about 8 thou, but I've got about 5 thou because I'm sure it'll all settle in a little bit. Anyway, I'm very happy with that. Unfortunately, the little micro camera just is not flexible enough for me to get it round to the back of the gearbox to show the mesh on top gear, on the sleeve gear. I just can't get it around the corner to show that. So I'm going to just put this together now. That's pretty well done. Everything is done. I've done as much as I can. I've checked everything, and I just have to, I'm going to put it together. I'm going to run this thing now with a sort of a power tool rather than do it on the lathe. That means I can have this in the correct orientation and have some oil in it, and I'll be able to see if some of the oil flicks up here and comes out and lubricates the little bearing that goes on the end of the main shaft here. So that's it for now. Well, it looks like I've overfilled it slightly. I'll let that drain away. The purpose of this little exercise is to see how long it takes for oil to get flicked up into this this little trough up here in the top part of the gearbox, so that it drains down and starts coming out the hole in here. I just want to get an idea of how effective this lubrication is. So this is all pretty dry. There's no oil anywhere. And I'm just going to put this rattle gun onto this and see what happens. Well, that hasn't been successful because there's oil coming out of this hole. I need to put a bolt in that. Well, look, regardless, there's lots of oil now coming out. It's obviously got flicked up into the trough and it's coming down and it's draining out. So I'm going to call that a successful bit of basic lubrication. So that's all ready now to have the cover put on. That's working well. Considering the very low revs per minute I managed to rotate that at. Right, I've just tightened up the last 2 bolts on this little cover over the main shaft. I've got lots of oil in it. I've tested it. I've gone through all the gears while I've spun the main shaft, and it's all functioning as good as it's ever going to be functioning. So I'm happy about that. That's the end of this 4-speed gearbox. I'm going to seal this up now and put it somewhere so it doesn't rust away. and that'll be there on the shelf ready for action. The next excuse me, the next project is something I've been thinking about for a long time. It may be of interest to some of you, but I'm going to make an electric roller start for the old Velocette. I noticed when the weather was bitterly cold that it was quite difficult to kick over with 50 weight. I like 50 weight oil, and I'm going to make an electric roller, a set of electric rollers which work off a battery, and I can start the thing even if it's very cold. Obviously it gets to the point where cold oil will not flow, but from my experience the issue really is simply getting the damn thing to make a spark. There's a minimum revs per minute that the engine needs to make a spark, and I was struggling to achieve that with 50 weight oil in it. So I'm going to sort that out, and I don't do an awful lot of motorbiking on the Velocette when it's bitterly cold, but the idea of not being able to start the damn thing when I want to, that doesn't appeal to me at all. So I'm going to sort that out, and that'll be the next video. You may be of interest. I bought, well, just as a scene setter, I've got some keel rollers from a boat trailer. I've got a little electric starter motor from a Mini. I've got a battery. I've got a load of pillow block bearings, and I've got a sprag clutch. I've got a load of sprockets, and I've got a load of chain. I've got and I've got a load of plate, aluminium plate. I've also got some 1-inch aluminium bar stock, so that I'll be able to chop that into lengths and use those as spacers. So I have enough bits and pieces now to just get on with it. So that's the next project, and I have a few more after that. Thank you very much. Bye bye. Well, this just gives you an overview of what the next project is going to be. First of all, we've got a starter motor and a relay, some connections, a choice of switches for the foot pedal, some connections, battery terminals, some aluminium bar, which is going to be part of the design that keeps the plates separate. Here's 2 lengths of aluminium bar. These are Anderson sockets, which should enable me to have the heavy cables here for the battery. I'll be able to have them, just plug them together. I've got 5 of these plumber bearings. I've got a sprag clutch which I have to insert into this sprocket for the drive from the motor once I take the Bendix off. I've got a little idler pulley here with its own bearings. That was convenient. That saved me the trouble of having to do it. And then I got a couple of taper lock sprockets with 20 millimeter taper locks. And the only thing I haven't put on the table here is some rather rusty pieces of steel bar stock, which I've got to turn down now into spindles. Oh, hang on, I've got to put the rollers. Right, there's a view of the rollers. These are just keel rollers from a boat trailer.